Hello everyone, this is Jiawei Yan, and today I will present the final milestone 6 of EtherMart, Advanced ETL of Orchestration, Data Governance, and End-to-End Security. And this presentation integrates everything we have built: hybrid database architecture, data pipelines, security, and governance to form a complete enterprise-level data strategy. Okay, let's take a look at the executive summary. In Milestone 6, I implemented three core capabilities. First, an automated and scalable ETL orchestration system using incremental extraction, watermark tracking, and cron scheduling. Second, a full data governance framework including metadata management, access control, audit logging, and data quality rules. Third, end-to-end security protection across EC2, MariaDB, SSH, and PLL data handling. This delivers a trusted and compliant data foundation for EtherMart's business growth. Okay, so here's the ETL architecture overview. The overall ETL pipeline architecture here, we extract the source data from our MariaDB Galera cluster using incremental extraction based on watermark tracking. The shell scripts automatically pull new orders, reviews, and customer updates, store them in CSV staging files, and record job history in the ETL-runs table. And we also build a reusable structure under OPT EtherMart-ETL to support logging, extraction, and automated scheduling. Okay, so to avoid full loads, we use a watermark-based ETL strategy. Each ETL job stores its last successful load timestamp in the ETL watermarks table. Only records that are newer than the last watermark are extracted. This efficient avoids reprocessing data and supports near real-time analytics. And this logic is implemented in scripts like extract-orders-incremental.sh. So that is the watermark-based incremental extraction. Okay, okay, let me show you guys the demo here. So here is a demonstration showing how the incremental orders extraction script works. We can see that the query uses the dynamic watermark value, extracts only new rows, generates a CSV file, and logs the process. The record count is automatically stored in the ETL-runs for audit and monitoring. So the GPT give us the script and we run on the MariaDB system, and you can see the watermark value is always -1, and you change everything and then become 2 is a level. Okay, so now let's take a look at the core scheduling for ETL concept. So on this slide, I explain how I automated the ETL pipeline using Linux cron scheduling. Instead of manually running ETL scripts, I created a master script called run all ETLs sh located in opt ethermart ETL. This script sequentially triggers the incremental extraction scripts for orders, reviews, and customers. To automate data execution, I used the cron tab and added this entry O2 blah blah OPT EtherMart. And this means it will run every night at 2 a.m. and it automatically extracts only new or updated data based on watermark. And it stores CSV files in the extractor folder and updates ETL runs table. And this automation ensures consistent and reliable ETL, supporting business dashboards and analytics without manual intervention. Okay, and this slide shows the actual core setup on my EC2 instance. After entering Cron tab, I selected option 1, Nano Editor, and inserted the schedule job line. Then I saved with Ctrl-O and with Ctrl-X. So to verify Cron was active, I use Cron tab -1, and this displayed O2, OPT, EtherMart ETL, which we talking about on the last slide. And this is very important because it proves master ETL script exists, start time is correctly scheduled, and Linux cron is working properly. And this is a real production style automation, which is a key part of the Milestone6. Okay, for the data governance framework, this slide introduces the data governance framework I implemented to make data trusted, protected, and well managed. I created 3 governance tables in the EtherMart ETL schema. The first one is DG Data Assets, Documents Data Ownership, Sensitivity PLL, and Business Purpose. The second is DG Data Quality Rules, defines integrity, validation, and accuracy rules. And the third is DG Access Policies, defines which roles, analytics, marketing, ETL can access which data and whether masking is applied. And these tables help EtherMart answer who owns which data, what data is considered sensitive, and how is data protected, and who can access it. This aligns with enterprise frameworks like DAMA, DMBOK, and the NIST data governance module. Okay, in this slide, I show how I implemented quality rules such as first, customer's email. Email cannot be null. And the second, order's total amount. The order total amount must be greater than 0. And number 3, review's rating. The rating must be between 1 and 5. So the purpose of each rule is rejects invalid customer data. Now email cannot be used for communication, and prevents orders with 0 or negative value, invalid business logic, and validates customer reviews, spam or invalid inputs. And these rules allow EtherMart to maintain high-quality analytics-ready data, which is essential for future AI pipeline integration. Okay, for role-based access control, which is RBAC concept. On this slide, I explain how I implemented database level RBAC using MariaDB roles. Roles created analytics-row can query transactional and aggregated data. Marketing row can only view masked customer info, and ETL row can run insert during ETL loads. And the key SQL command we used is create row, analytics row, and grant select on EtherMart Galera. I used the Galera instance. And the create row, marketing row, grant select on, and revoke select on, and set default row to analytics row for analytics user. And this ensures users only see the data they are allowed to see, which can protect PLL data and prevents unauthorized access and accident exports. Okay, here is the demo for the RBAC access restriction in action. This demo shows how RBAC correctly blocks unauthorized access. Command I run is MariaDB age. That's my personal IP address, and to start MariaDB, and then select from EtherMart Galera customer limit 3. And the result shows me that select command denied for table customers. And this proves analytics users cannot view full PLL customer table. Only users with marketing role can view masked version. And RBAC is working with real enforcement, not just a theory. Okay, here is the mask PLL view working. The command we still use MariaDB and myself's personal IP address and marketing users, and then select from EtherMart Galera VW customers mask the limit 3, and the result is visible in screenshot. The full name M. His email is maskedexample.com, and A is hidden@example.com. And this shows, which means marketing user can see data, but not original PLL. Real masking implementation supports GDPR, CCPA, and enterprise compliance. And now is the PLL masking explanation. This slide explains the design and logic, how I designed the masking logic. The implementation cycle, of course, is create a view, like view customers masked as select customer ID, concat left full name 1 as masked name, and a concat left email 2 as masked email created from customers. And the business value is marketing can analyze customer behavior without seeing names, which protects privacy and supports legal compliance. Okay, is the security firewall fail to ban and SSH hardening? On this slide, I demonstrate full infrastructure level security. The firewall is the first one, the firewall, UFW. Sudo UFW allow 22, sudo UFW allow 3306, and sudo UFW enable and sudo UFW status verbose. And fail to ban to block brute force attacks. Sudo systemcall enable fail to ban and sudo systemcall status fail to ban is the SSH hardening, disabled root login, and enforce the key-based authentication, block the password-based attacks. And this proves that my database and EC2 instance are both secure, hardened, and production ready. Okay, let's move on to audit logs tracking real queries. This slide shows how I implemented SQL-based access logging. Select from log data access. Recorded fields, username, role, action, assist, IP, query, timestamp. Why this matters? Because supports internal investigation, enables compliance with GDPR, HIPAA, and SOC2, protects EtherMart from legal and financial risk. Okay, here is the final integrated architecture. Here I explain how everything connects. First, MariaDB Gallery is a transaction system, and ETL scheduling and watermark is a data movement, and governance is a metadata sensitivity tagging, and security RBAC, masking, firewall, and fail to ban. And audit is accountability and compliance. And this architecture supports future growth, AI readiness, and trusted business analytics. Okay, now let's talk about a business impact. So first, accurate business reporting and trusted analytics and predictive modules, compliance-ready data handling, and lower security risk. Scalable, future-proof architecture. This is not just a technical project. It enables real business value. Okay, so for the AI tools used, I used AI tools like ChatGPT to help me debug bash scripting and fix MariaDB permission issues, and also optimize SQL queries, improve documentation and presentation, but all configurations, testing, and validation were manually implemented by me or on real AWS infrastructure. And this experience taught me that AI speeds up learning, but human understanding and execution remain successful and essential. But it do help me a lot. So that's it. That's everything. Thank you for your listening.